In this video, we're going to look at how to find the exponential function that goes through two given points. So I have these 2 points right here, -4, comma 1 over 54, and the other ordered pair is 2, comma 27 halves. So in these ordered pairs, neither one of them are the initial value. If that was given, that would make it a little bit easier. But in this problem, if we remember that for an exponential function, we know an exponential function is in this form. And right at this point, we don't know either one of those values. So we have to find both the initial value, which is a, and we have to find the common multiplier, which is b. So for this one, it's actually much easier to start with finding b, because we can find b using the relationship between these two ordered pairs. So let's think about what it would mean to find b. If I know that this exponential function goes through these two ordered pairs, so I know for an exponential function that there's a common multiplier. And I also know that if I look at the difference between these two ordered pairs, it's a difference of an input of 6, which means if we take 1 over 54, in order for us to get to this new output of this other ordered pair, we must have had to multiply by that common multiplier 6 times. Right, for each one of this, for the difference of the input of 6. So I had to take 1 over 54, and I had to multiply it by the common multiplier 6 times, because there's a difference of 6 between -4 and 2. That's how I would get my new output of 27 over 2. It's also, another way to think of it is that you can say, like, starting with sort of an initial value of 1 over 54, and we multiplied it 6 times to get our new value, our new output. So once we have this equation, we can solve it for b, doing a couple things. Okay, so the first thing we can do is multiply by 54. And if we do that, we have b over 6 equals, let's see, this will end up being, that's going to cross reduce, and we end up getting a 729. And then our next step to get b by itself would be, since it's b to the 6th power, I'm going to raise to the 1 over 6. That would get me a nice b. And if we did this, if we do 729 to the 1/6, we should get a 3. So that means in this function right here that our common multiplier is 3. And if we're not sure, if we want to just test to make sure this is right, if we took 1 over 54 and we multiply it by 3 6 times, we should get to our new output of 27 over 2. Okay, so let's now see if we can find what else we need to find here. Okay, so the next part of our equation, right, is for us to find our initial value. Okay, so we've got our b, so we know our function has a common multiplier of 3, so we know our function is looking like this so far. And we still are looking for that. Well, luckily we have 2 ordered pairs that can help us find a, which we could use either one of them. It's completely up to us which one we're going to use. I think it's easier if I have 2 ordered pairs and one of the inputs is positive. I think it's just a little bit easier because then you're raising your 3 to a positive number. So I'm going to use either ordered pair. To find our a value, our initial value. So again, we're going to use the 2. Let's move this up a little bit. So let's use our 2, comma 27 halves. And let's plug that in. So I get an output of 27 halves. I don't know a. I do know my b value is 3, and I know my input is 2. So let's keep going with this. So let's see, I would have 27 halves equals, this will be a 9a. Once I do that, 3 to the 2nd. And after that, I'm going to divide both sides by 9, right? So I've got 27 halves divided by 9 equals a. So you can do this on the calculator. You can also say this is the same thing as 27 halves times 1/9. And then let's see, I can cross reduce. This cancels to a 3. So I should get 3/2. If you did it on a calculator, you probably got 1.5, which is fine too. So there's our a value. So now we have everything for our function. So we know that our function would be f of x equals our initial value of 3/2 and our b value, our common multiplier of x. So that would be our full equation.